Alright, hello YouTube, thank you for watching. I'm working on this M800 messenger here. I got the board pretty much done for it, the board that was burnt up on it. So that's what I got, and zoom in and show you what she looks like. This is grossly overkill, but there's independent relays on this guy, and I was a little leery about doing this, and I'm not going to get into why, but I don't really like the fact that I did this on this unit. So there's 16 amp contacts on this guy, which is probably like 300 or 400% overrated. But anyway, that's what I had to use. Ideally, what I wanted, I couldn't find. The core transistor is just a 2S, probably a 2SB or 2SD. I don't know Japanese. It was likely an audio transistor. It had a good beta on it that I needed of around 300, 320 or so. So I ended up using that guy right there. The core circuit, I mean, there's really nothing to it. I played around with the values on that for a while. I think I got that down pretty pat. The preamps over here, it uses a BF, Philips BF199. The preamp relays here. There's also another 5-volt reed relay on the back side of the board that actually powers the preamp itself. The reason I had to do that is because this unit has some really unconventional switching, I guess you could say. If you were to look at a schematic for an M4B, you would see that the M4B switches power in order to carry out a function. But this unit is completely backwards. It switches ground. Don't know why that is. But anyway, I had to invert that, so I had to put a relay back here to give me inverse switching on the power to this preamp. The receive preamp seems to be working out real well. Unfortunately, today's a very, very dead day, except for a bunch of racket and noise down on like channel 9. Really horrible sounding stuff that nobody should be forced to listen to on the radio. So you're just going to have to take my word for it. The preamp in this is pretty fabulous. I think it does far better than any of the other ones that I've ever seen. That's the way that is. But I just put the scope here on, well, actually, let me back up here. Back here on the back, there's an Allen Bradley carbon comp terminating the input line here, because the whole amp is dead right now until I get my ducks in a row with it. So I just wanted to go ahead and check the switching and delay and everything and make sure I got it down to a science. So actually the connection on this board that flows into the input of the amp is actually on the back side of this board. It doesn't pull out the front like the other connections do. So there's it's lifted up from the board where this relay connection goes out and goes down to the board, and there's a 2-watt soldered back there just to dump it into a load when I key it up. And when I flip it off, it just transfers right through the relay to the other load. Hello, 1 2 1 2. Hello, 1 2 1 2. Hello, 1 2 1 2. I don't know, the switching transition, I might have to play around with that a little bit, but it looks like it's probably somewhere in the order of like 100 milliseconds, maybe a little bit more, maybe 200 milliseconds. So I might have to put the scope on in a different way in order to see exactly what the switching is there, the transition time. And then if I flip the box off, you can see it just transmits out to the antenna. So and then flip the box on, and then she goes right back into the box, and there's the transition time. You can see again from the SSB delay till it initiates where it needs to go. the preamp on this is pretty hot. It really is a pretty hot preamp. But there's actually, like I said, there's absolutely no activity at all anywhere today. But it works very well. So I'm just going to keep plugging away with this thing, and actually I'll show you what the back of the board looks like also. So I just put a standoff here, and I had to flatten the bottom of the standoff and grind it down into a half moon shape so it fit here with a PL259. Space was really cramped, so I was actually down to fractions of millimeters on this kind of stuff, and that's usually the case when I build something. Actually, I might have to shave a little bit off of this board because let me tell you what, space was a premium on this. We're probably a 1/16 of an inch too high, but some of the reason it's too high right now is because this board is stood up off the circuit board. The reason I did that, I just put some, it took me a minute to think of it. I just had to put some cambric tape down here because I didn't want this solder wick adhering to the board if I was going to have this board in and out of here a couple times, because I mean literally I would have had everything destroyed trying to get it out. So you can see it's just tacked in a couple places, very small, so it's not too much of a headache to get in and out, and I just put the tape under there to to keep the whole thing from getting soldered down. And then you see what I was talking about. I just the portion of the relay that comes out and goes to the driver comes out the back of the board because space was such a premium on this, trying to get things positioned where they were best suited to line up. So I just tacked a resistor there to simulate the input of the amp. It's pretty packed. I mean, there's literally not really room for anything on this board. So there's some stuff on the back. But it shouldn't be too bad. If anything were to ever go bad on it, it's not that bad to take out and work on. You just have to be careful because there are a couple spots that are close tolerances. But there's a little reed relay to switch the power to the preamp. There's actually a couple pieces of RG316 down there, and there's an RF choke jumping across to hit power to the bias board. I made the bias board for it, but I didn't get to that point yet of putting it in. I'm too busy worrying about or trying to figure out what I want to do about transistors in this guy. So, in this accessory plug, I'm really kind of questioning this, what its original purpose was, but me being the type of person I am, I like to utilize as much of the original things as I can. If I change something around, I don't like to tear everything out. I like to keep all the good points about the originality. So I kind of like to make an interface into this connector here. And the only downside to that is I might need additional circuit board space, and that's not going to happen, you know, to carry out some other functions. So it's very likely, well, I wouldn't say very likely, but maybe what I'll do is make a sub-assembly to this amp that plugs in here. Yeah, really don't know. Or I could just leave it the way it is. Who knows what'll happen. Just trying to think if there was anything else. I don't think so. It's pretty straightforward. Pretty straightforward stuff. There were some pads here that got trashed when the board burned up, so I rebussed them. Rather than use bus wire, I just used Teflon wire and epoxied it and tacked it down every 1.5 inches and epoxied it. Same thing around here. I just epoxied it down. um, it'll never burn up again, that's for sure. Strangely, the the crucial piece to this actually lies in this 3.3 ohm resistor right here. You know, as strange as it may sound, perhaps if this board would have had that on from the get-go, maybe it wouldn't to burn up. I just don't know, because I don't know what the initial failure was. But I attacked a 3.3 1-watt metal oxide here on the power line, and if the current on those relay coils or anything else, then there's really no place it could go. But I mean, in the 1 in a million shot, if that current goes over 250 milliamps, this metal oxide, he'll just start dropping off until eventually he'll open up. So that was that was kind of a key add-on to this. You know, an ounce of prevention is worth a pound of cure. So anyway, I appreciate you watching very, very much. I hope you have a good day.